Okay, the next problem, I need to find the antiderivative of secant squared 2x times e to the tan 2x. All right, I got this. What I'm going to do, I know that the derivative of something with a 2x and can't do that. Okay. I can't figure this out.
Hey Alex, check it out!
What?
Look what I made. It's a potion that makes you years younger.
Really?
Yeah, pretty cool, isn't it? I call it Brandelium.
How many years younger does Brandelium make you?
I don't know, I just made it. I haven't really gotten all the bugs out of it yet.
Oh, I see. Let me ask, what's the point of Brandelium?
Well, imagine if an old person took it. They'd become younger, healthier, they'd have a clearer way of thinking so they could solve problems.
Oh, yeah, I see. So, clearly there is potential in this potion. Can I try some?
No, I told you. I just tested it out. I mean, I can't... Hold on a second. Mad Scientists Incorporated, Chelsea speaking. So anyway, as I was saying before... Alex? Why did you take the Brandelium after I told you not to?
I thought it would help me solve these antiderivative problems.
It's a potion that makes you younger! What does that have to do with antiderivatives?
I don't know, I just thought that if I was a few years younger, it would help me think differently. I didn't know it would make me into a little kid.
Well, you can't stay like that forever. We need to think of a way to make you normal again.
Wait, don't you know how to change me back?
No, I told you. I just made it. I don't know how to make the antidote.
Is it called antidote or antidote?
Alex! Focus. Now, we need to think of a way to make you older again.
Chelsea, this isn't working.
Well, I've run out of ideas.
Well, there must be somewhere we could find the cure to Brandelium.
Oh, I know! We can look in the Holy Calculus Book of Calculus. Alright, let's see here. Let's see, Lavadium, Larcenium... Oh, here, Brandelium. Alright. It says that the cure to Brandelium is a potion called Abellium. What do the ingredients say?
Okay.
Let's see. Sugar, spice, and everything nice.
Those are the ingredients to Abellium.
Oh, no, sorry. That's for something else. The ingredients for Abellium are on the next page.
Those are the ingredients? They're so complicated.
Well, you better get started. It didn't work. You must have done something wrong.
Well, can you blame me? I mean, look at all these ingredients. Pistachios, almonds, Chex Mix, M&Ms, pretzels, raisins, lemonade, iced tea, oranges, mangoes, kiwis, apples, bananas, and strawberries.
Well, is there an easier way to make the antidote?
Well, we could substitute some of these ingredients. Look, at the bottom shows some antiderivatives on how to use the potion and use substitution to figure it out. And... What? No, stop. No. We're not doing lipid.
Anyway, I was actually working on some antiderivative problems like this before. They were really complicated, really difficult, and I couldn't do them.
That's alright. I'll do the first one, and then we'll see how you feel about substitution then. So here's the antiderivative. 6x squared over 4x cubed plus 7 quantity cubed. We choose a u that will cancel another part of the problem out to make it easier. In this case, u equals 4x cubed plus 7. Then we find the antiderivative of this, which is du equals 12x squared dx. Because we need to substitute for dx for this part, we use algebra to find that dx equals du divided by 12x squared. We then rewrite our antiderivatives with our new substitutions. We see that both the x squareds cancel out, and we have a coefficient of 1/2, which we can bring to the front. This antiderivative is much easier to solve if we change its form to u to the negative third. We find the antiderivative of this, which is 1/2 times negative 1/2 u to the negative second. Simplified, this is 1/4 u to the negative second. Once we solve for the antiderivative, we plug our u back into the problem to get our final answer. So you see in our last problem how we were able to substitute the 4x cubed plus 7. This was our u. This made the problem more easy to solve.
Oh, so maybe we can do the same thing with your potion.
Exactly.
Alright, well, we need to decide what we should substitute. And I have an idea. Let's replace the iced tea and lemonade with Arnold Palmer. Essentially, these are the same thing. But look at how much more manageable the ingredients are when they're all put into one package. And this package is much like the U that we would use in an antiderivative problem.
Yeah, but I feel like we can somehow make the potion better.
Are you saying that we should do another one of these integration problems?
Yeah. I'll do the next one, and you'll follow along with me. Here's the derivative secant squared x over 4 plus tangent x. A good u to use here would be u equals 4 plus tangent x.
Why would you use that U?
Well, if you look ahead with the derivative of 4 plus tangent x, you will see that it'll get us to cancel out the numerator.
Oh, okay. So in this case, du equals secant squared x dx. We use algebra again to get du over secant squared x equals dx.
Exactly. Here we plug in our substitutions. Both the secant squares in this problem get canceled out, and we don't have to worry about coefficients. We are left with the antiderivative of 1 over u, which in this case would be the ln of u.
So we replace the u in the final solution with 4 plus tangent x?
Exactly.
Okay, I think I'm starting to get this. Why don't we try substituting another ingredient in for the value and see what happens? Yeah, let's replace the pistachios, almonds, Chex Mix, M&M's, pretzels, and raisins with trail mix.
Spectacular. Now our problem is easier to solve. Alright. Since I did the first one by myself, you'll solve for this one.
Alright. Wait, I can't.
Why not?
This is the problem I was trying earlier. I couldn't figure it out.
But Alex, we need to solve this antiderivative to get to the potion. Alright? Now, you know how to do substitution better than you did before. You got this.
Alright, I'll give it a shot. Here we have a difficult looking antiderivative problem. It appears that if we set u equal to the tangent of 2x, then we will set ourselves up for success. The derivative of this is du equals 2 secant squared 2x dx. After some algebra, we get du over 2 secant squared 2x equals dx. We plug those into our original problem and see that the secant squared 2x's cancel out, leaving us with a coefficient of 1/2, which we bring to the front. This antiderivative problem is much easier to solve than what we were dealt with originally. In this case, the antiderivative of e to the u is e to the u, and we multiply in the coefficient 1/2. Finally, we plug our u in to get our final answer.
That's my boy.
Yeah, now how about for this one, we replace the oranges, mangoes, kiwis, apples, bananas, and strawberries for naked juice.
So our final ingredients are Arnold Palmer, trail mix, and naked juice.
Yep. Let's see if this works.
Hey, mister! Do you know how many strawberries are in each bottle of naked juice?
No. How many?
22 factorial.
22 factorial. Let me see this. What is that? It's a 22 followed by an exclamation point.
No, that's 22 factorial. That equals 1 quadrillion, 124 quadrillion, 728 billion, or something like that.
Wow, that's a lot of strawberries. It's too bad they can only fit in 1 1/3 bananas.
Naked juice.
Yes, I'm back to normal again.
It worked.
Oh, there's no way I'm ever gonna take one of your potions ever again.
Yeah, that didn't work out so well.
Yeah, but where did you learn how to make potions?
Gotta go.
A coincidence? I think not.